will be recorded, and as of this point now, we are in the recording mode. Let me maximize the slides. There we are, and as I said, we're going to be using Slido. Let me show you Slido. If you're not familiar with Slido, this is a good time to start because this is an interactive session. Just type slido.com, start familiarizing with the concept of Slido, and after the introduction I will show you how to log in. It's actually very simple. You type slido.com, and then in the barcode you would need to enter this number, and the number is in the presentation. So 54, actually let me copy this, let me type it, 548037. That is the code that you need to enter. Just type slido.com and here you enter the code and you will be able to access all the questions. Introduction about myself. This is me. Let me maximize this window. You can find a lot about myself on my work profile, and I don't know how to minimize this zoom, but I guess it has to stay over there. So that has to stay. You can type my name in any search engine, and the first thing that is going to show up is going to be my staff profile, University of Oxford staff profile. This is my departmental webpage, including a short biography, how to connect with different YouTube channels that I have, ORCID, Google Scholar, Scopus, Web of Science. So all my profiles are over there. Here's a whole list of the courses that I teach. If your organization has a subscription with Pearson's and O'Reilly, most universities around the world, they do have that subscription. So if your organization, if your institution has, when you click on the link of this course, you would be able to watch them. If not, you can get them on demand. Here are some of my books, which are also publicly available in most libraries around the world. I do present in China and the US and various different countries, so you can expect unbiased lecture here. So it's not going to be EU only. And actually, although I have 2 European passports, I don't have a European Union passport. I have 2 European passports and I'm not a member of the European Union. So the idea that Europe is European Union, it's actually quite bizarre. So this is mostly all that you need to know about me. If you want to connect, just type that name into any search engine. This will appear. So you will find my Alan Turing profile. I have a second job. I work for the Turing Institute that's based in the British Library. It's the National AI Security Center for the whole United Kingdom. Here you can find my Google profile, and on my Google profile you would be able to read all those papers are publicly available and free. University of Oxford has paid around £3,000 for each one. So when you click on it, it has open access, right? So which means you can get the actual PDF. It's not going to ask you to subscribe to a journal or anything else. It will directly lead you to the research. And if you change it, this is a good hint. If you change this by year, you would find my most recent work from published in 2016. That's a key word. While live sessions like this are more valuable for AI than papers, it's that is published in 2026. It's published now. This is January 2026. That paper was written 2 years ago. So the process of peer review takes a long time. And every time that you read written work, remember that for something, if it's not peer reviewed, it's almost not valuable because anybody can say anything. I can fly to the moon. You can say that in social media or in blog posts. If it's not peer reviewed, it means that nobody has checked it. If it's peer reviewed, that means that 2 independent academics that they don't know each other have been asked to mark, and the mark has to be checked by editor and the 2 people, they don't know each other. So one could be a professor in Australia, second could be a professor in Pakistan, India, Canada, God knows where. And they both have to send anonymous mark of, let's say, pass or fail for that work to be deemed credible for publication. That's what the peer review means. And here you will find all my peer review papers. If you want to connect, here's my LinkedIn profile, which will appear if you just type my name. So you can just accept me there and send me messages for future references if you wanted to. Now that is enough of introduction about myself. For the future courses, hopefully I won't really be introducing myself that much. Let's start with the PowerPoint slides because we do have a limited time for this session. So Hopefully you have introduced yourself with Slido. If you don't know how to use it, as I said, just type slido.com in any browser, paste here the code. You don't have to log in, you don't have to sign up. Those are not required. You can be completely anonymous on Slido. Now let's go back to the slides. This session today is on AI security foundations for law and business. That is the specific that we have. I am from the University of Oxford, but this is a session held in the University of Warsaw. That's why I have added the logo over there. We're going to be talking in this session about business, emerging AI-enabled threats, and this here, it's my area of expertise. So from this whole title, if you type AI security and threats, that is my area. I work in attack and penetration. Security is predominated by two teams, blue team and red team. Blue team is defense, red team is attack and penetration. So basically it's like little children playing a game. One of them is trying to attack the second team, and the second team needs to defend the perimeters. Whoever succeeds gets a point, +1, +2. And I'm in AI security in the red team. So that is what you can expect from the session, because that's my perspective. There are other people in this course that they will be teaching you more ethics from a philosophical standpoint, and that is perfectly valid. I'm actually quite interested in those sessions. I attend them quite often, but I'm not a philosopher. I'm coming from a very technical background, and I think in the future everybody's going to be technical, because ChatGPT is now writing code better than many software developers. So being technical doesn't actually mean much, but that's my background. I'm not a philosopher. So here's a beautiful picture about myself taken from a photographer, and this will feature in every presentation that we have. I work for the Department of Computer Science in the University of Oxford. We already covered that. Next slide. I do have many hats. So you would see me in various different positions. I teach with Pearson and O'Reilly. That's in the US. I work for the Turing Institute. I've done some lectures for the Swiss Cyber Institute. I present in Saudi Arabia. So those adversaries, traditional enemies, the boundaries for me, they don't exist. So I can be presenting in China one day, in the US a different day, in Brussels a third day. So politics, it's not something that affects my work. If you want to check me on Scopus, I have H-index of 27, 4,000 plus citations. That is traditionally how do we mark the quality of a researcher. So if people are citing your work, and if you have high H-index, traditionally that has been associated with a good productive researcher. Now we have shifted towards DORA framework, Declaration of Research Output, which is a San Francisco framework, and those H indexes are, some people think they are less valuable, and that's not the case. You still need to have very high index, but then there will be a second check to make sure that actually you create impact in the society. Previous jobs that I had was, I was a postdoc in Cambridge, Imperial College London. I was a Fulbright Fellow at MIT and University of North Carolina, that's in the US. With this kind of course from a law and business perspective, I was thinking what is the key requirements. And by the way, if you cannot hear me, if there's any glitches, please send a message. I won't be able to hear you. It's because this is recorded and I don't want anybody to, if this goes live on YouTube, I don't want to, your voice won't be able, I won't be able to edit that, because once it goes on YouTube, it's gone. That's why the safest way is to have you muted, and you can send me a message. I will read. I check messages quite frequently. So from a law and business perspective, the most important frameworks that you need to know are here. MITRE Atlas, NIST AI research framework. We'll cover all of those. NIST is the US risk management framework. ISO, these various different ISO frameworks. This is just one. In the slides, I will show you what is my criticism about ISO, but here let me start with saying why do I think you need to follow ISO. ISO is about compliance. If you want to show compliance, you need to have ISO. NIST is not based on compliance. NIST and MITRE, those frameworks are designed to secure your organization. And from a law and business perspective, you need to think about two separate. So are you thinking from legal or from a business perspective? Are you, let's say you're a business owner, you're a business graduate, and you want to start your own business. What is your main concern? Well, number one is not to get hacked, because if you get hacked, the hackers might require ransomware. Ransomware is very profitable. In recent years, actually more than 84% of the ransomware has been paid if it's higher. So the higher the ransomware request, it's paid because they know when to request higher payment. If there's some national critical infrastructure, for example, and if the request is more than 3.5 million, it's around 85% success rate, regardless of what institutions tell you, because institutions don't want to admit that they have paid ransomware, but the hackers are reporting 85% success rate if the ransomware request is 3.5 million or more. So what is your first priority if you're a business owner? To secure your organization, and MITRE, Atlas, and NIST would be very helpful with that. I'm going to demonstrate how they work. But with MITRE Atlas, it will say, okay, this is the newest attack that happened in China or in Vietnam, in Indonesia. And security teams are already in that framework. They're already building patches, installing and putting reports and advisories on how you can mitigate that kind of attack. So you would be aware that the attack exists before it actually reaches your organization. Or if it has reached your organization, it's very unlikely that your organization is number one to be hacked. It could happen, depends. If you work for the Bank of Poland, could be. But if you work for a startup, if you just started your own organization, it's not likely that you can be the first target. Somebody else has been targeted before. That means MITRE Atlas will have a solution for you. So you will be able to rectify, to correct that error and continue with your operations. I will demonstrate how you can use the MITRE Atlas framework. The NIST research management framework, and anything that is based on NIST, it's more about how to do it. So, okay, you need to secure your parameters. How? It's a question. How? ISO and the European Union Act, they are not based on how. They're based on what. What do you need to do? So, if in order to be compliant with the European Union AI Act, you need to have X, Y, Z. How do you do that? It's not really part of the framework. They will have some small guidance, but because there is a whole set of diverse organizations, they don't actually control everybody, so they're not designed to impose steps. They're just saying you need to, European Union GDPR, for example, you need to protect all the data. You need to ensure that there's a data minimization. You can only use the data for the purposes that was collected. So if you collected my data for a specific purpose, that's the only purpose you can use it. If you reuse that data without approval, boom, penalty. If you share that data with another organization, boom, penalty. So they are telling you what you need to do, but they're not telling you steps of how to make sure that that is compliant, because it's a compliance. It's a mechanism to make sure that your organization understands that there's penalties that you will have to pay. But that is more from a legal perspective. That is what the lawyers would ask. Clearly, as a business, you need to be compliant, but those are more legal framework, where MITRE Atlas and NIST frameworks are more designed to give you flexibility to find solutions if you're running your own business. Now, we'll cover that in a lot more detail. We already spoke for 5 minutes on this slide, and I have many slides and many demos and many questions so we have to move on. We'll cover all of those frameworks. This is an introduction. Here there is some interesting key objective text which you can read in your own free time. I'm not going to read the text from the PowerPoint slides. That's dead by PowerPoint, and I'm using those notes just to guide me in the presentation to know what I need to do, but I'm not actually going to read that. So here I can see AI BOM. That stands for AI Bill of Material, and that's the newest effort that comes from the United States. AI Bill of Material will cover that, but AI Bill of Material provides transparency, and it's a way how to be compliant with the European Union, partially compliant with the European Union Act, but it's from the United States. And as you can see in the question, how or what, AI BOM is telling you how. So you need to do specific steps to make your AI Bill of Material transparent. But that will make you compliant with the European Union AI Act. So it's not really that they are isolated, they are linked, you need to have them all. So quite often people that are new to security, new to cybersecurity, they politicize this. So they say, I live in the European Union, I only want to have the European Union, I don't care about anything else. Yeah, fine, but how? How are you going to do it? European Union AI Act is not designed to give you step-by-step instructions. It's designed as a framework to impose regulations as soon as something is detected as problematic. So they will say, okay, you know, if you have, let's say, imagine you're building a house. They're not going to tell you how to build your house, but they will impose standards on what kind of materials and parts to use. That's what the European Union AI Act is. AI Bill of Material is completely different. It actually gives you a transparency of the material that is used for that AI model, including the data. And that is enabling the regulators to check your building, so to speak, of what kind of material has been built. Is it safe or is it not safe? Without that, it's very difficult to check. I honestly don't think there's a way how to show complete transparency with the European Union AI Act if you don't have mechanisms like that. Post-quantum cryptography, it's something that we're going to be covering in other sessions. So this is all based from NIST. NIST is the leader. Actually, China is competing and presenting alternative process for the post-quantum cryptography, but they don't actually have standards yet. NIST has been doing this work for the last 10 years, but that's going to be part of a different session. So with me, you're going to have a whole list of sessions. Post-quantum cryptography is going to be a different session. Agentic AI, it's something that brings elements of risks, and we're going to be covering that again, mostly in a different session. So moving on to the next slide. Why security is now a legal and business imperative. And I hope that you have mastered the use of Slido, because quite soon, next slide, I think we're going to have a Slido question. And I'm going to ask you a question and you're going to have to answer. You're going to have, because I'm not getting many questions in the chat. So I'm just mentioning this, that there will be a question in the next slide. So hopefully you have learned how to use Slido by now. Why AI security is a legal and business imperative. AI systems, they now make influence legally relevant decisions. There's also a shift, regulatory shift from best efforts to control, that you need to demonstrate control. And courts and regulators are increasingly assessing foreseeability of AI misuse. So they're trying to predict when something is going to go wrong, and traceability of AI decision. So we're shifting now from cybersecurity as IT hygiene to AI security as a regulatory duty, a responsibility. Now, let me move my face a little bit away, because I'm going to try to zoom into this image that is here. Okay, bringing back my face. There we are. So this is a very brief categorization of artificial intelligence models, and actually most people focus on AI risks that dominate models from 2016 to 2022. This is predominantly the discussion that you hear in every presentation, in every lecture, even in Oxford. And that's a problem, because this is not how AI is not statistics. Linear regression was the very first machine learning model designed in 1905. That was before we even had computers. So we had a long time to check the security of those traditional machine learning models. And most of the academic lecturers, they are used to teaching with the same PowerPoint slides for the rest of their life, for the entire life. Actually, I had a teacher in my master studies that used his slides on probabilities and statistics from the first day that he started lecturing until his pension. AI is not the same. You cannot teach that way. And if you are used to that, and many professors are used to that, because creating new material over and over and over is difficult, it's very time demanding. They don't have that because they're doing many other things. They're managing like 500 students sometimes in some institutions. They have to write research grant proposals. They have to do administrative tasks. So they don't have time to update their slides all the time. That's not possible with AI. With AI, things have changed. Everything that I was teaching 3 months ago, gone, completely new now. So let's look at this. Let's simplify it. Let's teach. Let me teach AI in the way that is taught in the university settings, and then we'll change this. If you try to categorize AI into some categories of attacks, you can put it into three categories. So you can say you have evasion attacks, you have poisoning attacks, and you have extraction attacks. Those are three categories. At which stages of the AI development they happen? So the first one, evasion, starts at inference time, and this can mislead the model without changing the internal parameters. Now think of an image of a stop sign. So imagine that you are driving a car and you see a stop sign, and you're in an autonomous vehicle, and your vehicle doesn't recognize that as a stop sign, it sees it as a speed up. That's the most common example that we use in teaching of why sometimes AI, full control of AI is not useful, because you can actually manipulate. Has this attack been demonstrated? Yes, it has been demonstrated over and over and over again. So imagine that you have an image of a stop sign, you can just delete, erase some parts of it, put a sticker, yellow sticker here, blue sticker there. To a human eye from a distance, you would just see the stop eye sign, but for the AI, it would read as a completely different sign. And how much time do you have as a driver to focus on checking the blue stickers and the yellow stickers on the traffic signs that when you're driving a car? It's not possible. You have to focus on so many things. So this attack, it's a real problem at inference time. Poisoning attack. Poisoning attack here. This happens at the training time when you're training your model. You can inject malicious behavior into the model internal logic, and the example here is a small number of training images with hidden patterns that can cause the model to misclassify specific input, and they can corrupt the learning process with modified or malicious training data. Poisoning attacks, actually they are shifting now towards number one of types of attacks, but it's not just poisoning attack, it's poisoning attack on supply chain data. So you can control your own model and your own data, but you don't control the supply chain. Many things that in software development, they rely on third parties, and you don't know what those third parties are doing and what kind of checks they're doing. So that's why poisoning attacks from a third party data, when somebody else has been attacked and then that data is fed to you, that is a serious concern. Extraction attack, we're going to talk about extraction a lot, but it's basically when let me give you an example of ChatGPT and DeepSeek. ChatGPT invested loads of money, OpenAI invested loads of money in advancing that model, and that's why we're going to talk about AI bubble. That's going to be part of a different session. Depends on how much time we have. But why are these companies like OpenAI, NVIDIA so valuable? Why are they share prices are so expensive? Because they have invested a lot of money in a specific technology, and the assumption is that only they can do that work. That's why they're so valuable. That's why NVIDIA share prices keep going up. That's why OpenAI share prices keep going up. But what if a different company can show up on the market and do exactly the same job or an almost near identical job for a fraction of the cost? Well, that means that this OpenAI and NVIDIA, they have been artificially inflamed, and their prices need to drop. It will basically collapse. The bubble will burst, and the share value will go down. So that's what happened with DeepSeek. DeepSeek is a Chinese algorithm which showed up with. It was designed for a very fraction of the cost of what OpenAI does. And then OpenAI got angry because they said, you stole our model. You extracted our model. That's the extraction attack. Legally, DeepSeek didn't do anything wrong. If they wanted to start a legal case against DeepSeek, there was nothing they could do. There was no legal grounds for that to happen. Now, in other sessions, I will show you the actual reports that the transformer architecture that is used by OpenAI is not actually developed by OpenAI. It's not developed by ChatGPT, or it's developed by Google researchers, 5 Google researchers, year before OpenAI and ChatGPT was created. So you can say that OpenAI stole the idea from Google if you wanted to present that narrative. There's no legal case for OpenAI to sue Google or vice versa. It's just knowledge. So they have extracted some knowledge, and that's it. So extraction attacks are very problematic because in the future it might be very difficult from a legal perspective to confirm that somebody has stolen your model. And how do they steal the model? What do they steal? They steal the weights. So if you think about a model, when you train a model to learn how to distinguish between a cat and a dog, between a cake and a carrot, what's in the model? There's no images in the model. They don't remain in the actual model. There's weights. That's weights are connecting points, mathematical connecting point between two neurons. So the actual connecting point is something like 0.01347. The next connecting point might be stronger, so it's going to be 0.04375. But that's all that there is. And if you're stealing that, then you're stealing the response rate and the prediction rate of that model. Is it a problem? Well, extraction attacks are going to remain a problem for quite some time. Moving on to the next slide. This is when you had sufficient time now to learn how to use Slido. And if you still don't know how to use Slido, I'm going to move my face out of here, scan this barcode with your phone, or just type slido.com in any browser and then paste this code here. So I'm going to have a drink of water just to give you a chance to do that. Once you have done that, then we're going to ask the first question and we're going to start using Slido. There's no questions, which means that you know how to use it. So I'm going to proceed with that. Let me move my face back over here. Hopefully you have scanned the barcode. If you didn't, Slido, then the code. Now let's go to Slido. So the first question was on the slides: what do you see as the primary risk of AI systems in legal and business context today? And I'm trying to... okay, so there's lots of questions. People actually know how to use Slido. I was not giving you enough doubt. So here... let me find that question. Hold on, let me check my slides here so I don't have... okay, so this is it. I do apologize, I was checking my slides, and I'm gonna answer those questions I'm gonna give people time to use this word cloud, and I'm gonna answer the questions. So let me push this. I'm starting the poll. Now, if you don't know how to use this, it's very easy. You type a word and the word is going to show up here. Oh, first person. There we are. Ethics. Somebody typed the word. This is how the Slido will look on your phone. So if you're using your phone, this is and you just enter a word over there. Now, if you wanted to open this, hold on, as in a browser, so this is how the browser will look. So if you open this in the browser, your browser would look like this. But I'm gonna wait for some more people to ask questions here. This is live, and the question is why AI security is now a legal and business imperative. That's the question. So this relates to the slide. In just one word, what do you see as the primary risk of AI systems today from legal and business context? Now let me look at your questions, because you do have some questions here. What is your take on preprints? What is my take on preprints? Preprints, as the name suggests, is something that you publish before printing. So what is the value of a preprint? You make your work publicly available in case your university does not have the budget to pay the open access fees. Preprints does not mean that you can just type something and submit it as a preprint and get it published. There's no value in that. You're trying to cheat the system. And let me show you what's going to happen with preprints. So hold on. Let me open my other screen here. So if you have preprints, loads of preprints, they will be publicly available, and eventually this citation mark here on Google Scholar is not gonna match the citation mark on Google, on Scopus and on Web of Sciences. Why? Because Scopus and Web of Sciences only consider journal publications and preprints are not. So they will be, you will have like 4,000 here and 0 on Web of Science. And that will create disparity. That's why we have the DORA research framework. So DORA research framework. This is the San Francisco Declaration of Research Assessment. So it means that somebody will actually assess your work. It's no longer just looking at Scopus here. A second thing about preprints is you have to be careful what you publish nowadays, because that thing, Archive, for example, does not accept any more preprints of review papers. So if you have a review and you want to publish it as a preprint, Archive just won't accept it, because it's ChatGPT can write very good reviews. So preprint, in my opinion, is, let's say you have a journal paper like this. This is from Computers in Industry. Computers in Industry is one of the highest ranked journals in my category. So if you type Computers in Industry, you already know that, talking about the DORA framework. So here you have Shimago. I'm showing you that there's a way how to check this. It's not something you can cheat. So you go to Computers, you go to Shimago, and Computers in Industry, here it will tell you it's Q1 paper and it has H index of 139. So it has very high ranking. Therefore, it's a credible journal and it has citations. That means that in terms of the DORA framework, this is okay. But imagine that you have just preprint after preprint after preprint and they're not coming from credible journals. First, your Scopus profile will suffer, your Web of Science profile will suffer, and the numbers between Google Scholar and Scopus are already different, because here you have all the reports that you're writing. They're not listed on Web of Science. So if you have, let's say, 1 million citations on Google Scholar, you might have 100,000 on Scopus and on Web of Science. It's going to be a lot less, because reports are not included here, PowerPoint slides are not included here. Many things that they are listed in Google Scholar are not actually listed in Web of Science and Scopus. So imagine that you have 100,000 citations on Google Scholar because of preprints, but you have 0 on Web of Science. Academically, that's a problem. Second thing is preprint. Basically, it's just once your paper has been accepted by the peer review, once the editor has confirmed that this is done, once the proofs are finished, before they actually put the logo of the journal and they publish it to the rest of the world, if your university does not have open access fee, sometimes 3, sometimes 5,000 pounds, if your university does not have that money, you publish the preprint so everybody can read your paper, and the journal is okay with that. As long as it doesn't have the journal logo, the journal name, the final version of the text, the journal would approve it. Another reason why you would use preprints, if you have intellectual property and you don't want that journal to have any ownership of your intellectual property. If your paper does not contain intellectual property, it's not a patent, or if your journal is not being accepted, there's really no need to publish any preprints. It's just going to put you in trouble. It's not going to improve your profile in any way. You really need to, work your way up. Now, that's the first question. Can you share what's your work on agentic AI entails? On what applications can you focus? What my work on agentic AI and what can I focus? Okay, let me show you. Let me demonstrate that. This is going to be a very quick. This agentic AI security bootcamp that I'm teaching with Pearsons and O'Reilly. This is in March. So if your university has a subscription to a digital library, then you will have access to Pearsons and O'Reilly, and you can sign up to those. So there's 4-day teaching on agentic AI. And what do I teach? AI model observability, securing AI from the data layer up, AI architectures and infrastructure, and red teaming. So this final one is my specific area of focus. I work on red team, as I said at the beginning. I work on attack and penetration. So I'm trying to penetrate different systems. But if your university, if your institution has a subscription to the O'Reilly Digital Library, Oxford has, many universities, many companies have access. So you would be able to log in and get not every single book and not every single report, but most of them, they will be there. So, do you think AI Act and other European Union regulations may decelerate AI development in European Union versus China? Short answer: yes, I do. This is going to be part of the slides, so not to eat in out of the slides that we'll cover, but short answer: yes, I think it will. It will inevitably. Uh, Once you start over-regulating specific sections, they won't really develop that fast. So this person anonymous here has typed privacy and cybersecurity. Those things, they need to be typed in the actual question. So here, let's look at the Google Cloud, not the Google, the Slido cloud that we have created. This is the cloud, and just to move my face out of the way here, how do I move this? Okay, let me move this slightly like that. Privacy has been seen as the biggest problem in terms of why AI security is now a legal and business imperative because of privacy. Other copyright, ransomware, intellectual property, sovereignty. That's an interesting one. Sovereignty. Whoever leads the world, whoever leads the development of artificial intelligence, you can also say that it's going to be leading the world. Xi Jinping agrees on that. Donald Trump agrees on that. Most of the countries agree on that. So why is the European Union not developing AI models? That's a question that you can only ask the European Union. It's possibly related to capabilities and regulations. So sovereignty, it's really European Union is working hard now on developing AI for defense. It's the wrong approach. Once you develop AI for defense, that could have dual use. That could be also for attack. Regulatory pressure, yes, regulatory pressure, necessity, safety, privacy issues, employee using AI on their own without regulation. That's called shadow AI. It's part of a different session. Or maybe this session, I don't remember. Once I get to that slide, I will cover it. To secure our privacy, it can lead to legal liability. This is an interesting one. Legal liability. Legal liability, regulatory pressure. So basically, you're going to pay money. And European Union AI Act comes into force as of 2026 this year. So there's some talks about changing it and postponing it to allow organizations to adapt, but so far that has not been confirmed. So the European Union is pushing, and the excuse that they have is privacy, yes, but on organization and from legal perspective, there's going to be penalties. So European Union AI Act is based the same way that GDPR is. If you're non-compliant, you pay a penalty. Going back to the slides, we have covered that. We have many more slides, so let's see what do we have here. This is a slide on AI attacks versus traditional cyber attack. It's an interesting slide because key distinctions: traditional cyber security versus AI security. With traditional IT security, we assess it with static software, sometimes with dynamic or hybrid, but quite a lot of IT security is done with static software, which means that we don't run the code in live environment. For that, you need a sandbox. For AI security, you not only that you need dynamic, but you also need adaptive probabilistic behavior. Probabilistic means that you predict what is going to fail in the future, not like you wait for something to fail, then you scan it. That's the way how we do it now. Traditional IT security is deterministic failure modes, patch-based remediation, it's patch and pray. So you find vulnerability, you find an exploit, you patch it, you install an update. That's why you get an update on your computer. Many people still think that updates are to slow down your device. Actually, the updates are designed to patch vulnerabilities on your system. If that has been abused in the past once or twice, and that has been enough to create a significant conspiracy theories, so people don't want to install updates. If you're not installing an update, you're not installing the patches to the known vulnerabilities and known hacks. So your mobile phone is exploitable. Hackers can penetrate your system because security team has detected that vulnerability, developed a patch, and sent that as an update. That's not really going to be that easy with AI. Once we have AI operating models, you cannot just install a patch and fix it because the whole logic of the operating model is being compromised. And you don't know when a sleeper agent would get activated and starts causing loads of damage. What are the implications for law and business? Liability changes with data breaches, and harm can come from the model behavior, not only from a system behavior. In other words,
Currently, a hacker needs to penetrate your system in order to create harm. The AI would be able to create harm. AIs can malfunction. That could happen many, many years after the hack has been installed on your device. So once you have built a full trust into your autonomous vehicle, into your autonomous system, boom, that's when it could happen. That changes from a legal perspective. Who do you blame then? The manufacturer? The manufacturer might go bankrupt by then. They might say, well, how do you know it's our fault? You've been using this vehicle for 10 years. Now moving to the next slide. Here we have another question. So we're going back to Slido. And the question is, which characteristic most fundamentally differentiate AI security risk from traditional AI security? Now, I'm going to go to Slido. I'm going to push the question. And so hold on, I'm going to push that one. And this is a multiple choice question. So you're going to see this, and the multiple choices will review this once you had a chance to click. So the question is, which characteristics most fundamentally differentiate AI security risk from traditional? What's the difference between AI and traditional security risk? We already spoke about that. We covered it in the slide. This is a question for you, not to wait until the end and ask you a question. This is a question I'm asking you now. Did you understand that slide? If not, you need to reread it and rewatch. This video is going to be publicly available on the internet, so you can watch this video in the future. Now, I'm going to be going through the other slides, and I'll come back to this question. So please do answer that. I just don't want to waste too much time. We won't have time to cover the slides if we did that. Now, this is a quick introduction to MITRE Atlas. MITRE Atlas is a framework. What is MITRE Atlas? It's a structural knowledge base targeting specific for AI system. MITRE ATT&CK is for traditional IT operating systems. Atlas is for AI models, because many of the attacks, they are linked. Actually, systems are secure by design and secured by default. It's not 1990s anymore, and nobody can penetrate a system with a single approach. So when you're looking at at AI attacks, usually it's a combination of different attacks. But they're different. AI attacks and AI risks are different than traditional security. That's why we have MITRE Atlas for AI risk, and MITRE ATT&CK is for traditional IT security. I do have some screenshots, and I'm going to show you the actual frameworks. But the scope is that the training time attacks, inference time attack, post-deployment, and human-in-the-loop manipulation, that's the scope of the framework. Why it matters legally? Because it establishes known attack patterns. That means that we know these attack patterns exist. So legally, if you're not ensuring protection against that, and if something happens to your organization, you cannot say, oh, I didn't know that existed. I don't know anything. From a security perspective, why is this important? I do have friends that they earn 10 times more than me, a lot more than me. The money that they earn per month is my monthly salary, my annual salary in academia. And they leave cybersecurity. They leave their jobs. Why? Because what is the measurement of success for successful cybersecurity manager? It's nothing happens. That's the most credible measurement. If nothing happens, if nobody hacks you, if nobody encrypts your system and requests ransomware, if nobody blocks your IT services, if nobody damages anything, that is the measurement of success. So what happens then? An accountant will show up on a meeting and say, hey, we pay this guy $500,000 here. Academics get paid 30,000. He gets paid $500,000. Why do we pay this guy so much? Nobody has attacked us. Nobody has penetrated our system for 10 years. We're very secure. So they cut his salary. He leaves. And then the hackers would penetrate the system. But organizations won't be able to do that because now we have established known attack patterns. So when you're cybersecurity professionals, you would be able to go and say, at least you would be able to go and say, hey, these are the attack patterns. That and that organization has been hacked with this and this types of attacks. If I didn't impose these security mechanisms here, your organization would have been hacked, and you would have had to pay ransomware. You have some legal justification over there. Now let's look at the next slide. This is how MITRE Atlas works. It's basically a table. Think of it as a table. It's going to get more complicated once we look at it, but think of it as a table. So you have a technique, let's say initial access. That's a technique. A hacker can conduct reconnaissance for initial access. Actually, reconnaissance is a different tactic. But you remember, maybe your organization has been subjected to phishing and you want to protect your organization today against phishing. So you clicked on that box, it will give you remediation. That's how it works. I'll demonstrate it. Very simple. It's not designed to be technical. It's designed for you to find the solution. So it represents the attack stages. So it will tell you, let's say, is it data labeling and label manipulation, model. Label flipping is when that's for supervised learning. It's going to get too much. We'll cover that in a different session. So if it's a prompt injection and jailbreaking, there's a different solution for that. And the legal relevance is that predictability of these attack vectors undermines the unforeseen misuse of defenses, and the failure to mitigate known Atlas techniques might imply negligence. So that is, as a cybersecurity profession, that's what I would argue to an accountant. I would say, if you fail to impose this, that's negligence. So that's why we have to do this. Going to the next slide. And this is a slide that I'm gonna come back to. I just gonna show you, I'm gonna demonstrate how to find MITRE ATLAS and MITRE ATT&CK, because I'm not certain if we're gonna have time in future sessions to cover them in more detail. So that's why I'm gonna try to show you how it works now. Let me just go back here. Attack. This is MITRE ATT&CK. So just type attack.mitre.org. And we said it's the table. Think of it as a table. This is the table. And you think that somebody is actively scanning you. So, okay, you click here, active scanning. This is the definition of active scanning, procedure examples, and mitigation techniques. So here you have mitigation techniques for pre-compromise. And it tells you this technique cannot be easily mitigated with preventive control since it's based on behavior performance outside of the scope of enterprise defenses. So efforts should be on minimizing the amount and sensitivity of data available to external parties. That is the mitigation techniques. Here is the detection strategy. And if you want pre-compromise mitigation, here is the longer discussion on that and specific techniques that are addressed by mitigation. So by that mitigation technique, acquiring access would be prevented, for example. But let's pick a different one. Let's pick account manipulation here. This is under persistence. There's 23 different techniques under persistence. Let's click on one. Account manipulation. Procedure examples. So here we have examples of Ukrainian electric power attack. And the mitigation, you can disable or remove a feature program. You can apply multi-factor authentication, you know how to do that. You can develop network segmentation. You can develop operating system configurations. You can have privileged account management. Here it's describing what does it mean to have privileged account management. Again, you don't have to be a cybersecurity professional to understand this. This framework is extremely easy to use. It's designed for everybody to be able to use it. Just many people get confused about these links and what do they mean, what's mitigation versus detection and yada yada yada. Now, MITRE ATT&CK and MITRE ATLAS, as I said, they're coming from the same organization. So let's look at the MITRE ATLAS now. MITRE ATLAS. In a few seconds it will load. So if you go to MITRE ATLAS, this is how the framework will look. If you go under resources, which is here, resources, Atlas navigation. What you'll see here is exactly the same table. It's going to show up in a few seconds based on techniques and boxes. So MITRE ATLAS and MITRE ATT&CK are very similar frameworks. Obviously, as I said, Atlas is specific for artificial intelligence and ATT&CK is more for general purposes. You have to keep that in mind. But apart from that, they're extremely easy to navigate. Now, going back to the slides, let me just go back here. What's the difference and not the difference, well, the difference between NIST, ISO and MITRE ATLAS, we already covered that. But to contradict when people say that I only need to be ISO compliant, okay? ISO 27001, that specific compliance mechanism does not really include
AI specifically. It's still working on it, and it's going to take some time for ISO to develop that. They have alternative standards that they're under development. But if you're, let's say, if you check MITRE Atlas and if you apply these techniques, root hijacking, tool abuse, you're going to be compliant with ISO A.9 and A.14. You also be going to be compliant, which is, they're not compliance based, NIST is not compliance based, but you also going to be covered for regulation AC/6 and PL/2. So you can create a table like this and show people how your organization is covered for multiple security frameworks, not against single one. But quite a lot of people, they don't understand that these techniques are linked. That it's not, if you're compliant with MITRE Atlas, if you're applying those techniques, does not mean that you're not compliant with ISO 27001. You just need to be able to create a table and populate that to convince people and to demonstrate how you're compliant. So how would you say, if somebody from ISO comes and says, hey, how do you know that you're compliant about this? Let me challenge you. How do you know that you satisfy regulation A.9? You say, okay, because we have two whitelisting and sign plugging, and they're designed for root hijacking and tool abuse. You're going to say specific technique that you have developed. There you are. That is it. And this is the approach that really we need to start thinking about. It's not like NIST is developing or ISO is developing or MITRE is developing, competing. They're not competing. They're kind of different aspects. Imagine that you're baking a cake or cooking in the kitchen. You have different tools, right? So you're not cooking with a single spoon. You have those are different tools. You need to be able to understand them all. Problem is that many people only understand one and they don't understand the other one. They don't even know what does it mean, NIST SP 800. So when they say, oh no, I'm ISO 27001, and as if that means something, it doesn't. I have explained that in far greater length, and I hope it did sink, because it's really important that it's not really about following blindly specific standards. It's about being able to protect your organization and to have backup in case there's a legal problem. So systems will fail. Your system is not perfect. You cannot expect that nobody's going to hack your organization. That's not how it works. Somebody will hack your organization. Then you have to justify that you have not been negligent. That's the first thing that you need to confirm, that you have not been negligent. And second is that you have applied all the reasonable expectations. So creating tables like that will say, okay, look, we tried really hard. They got on our case, they got us. What can we do? We'll fix it. MITRE attack mapping for prompt lock. So this is the prompt lock ransomware, and this is how it was mapped. I'm not going to go through this exercise because it's in the presentation. You're going to get the slides, you're going to get the video, and it's very, very self-explanatory. We said tactics, technique ID, technique name, description of use in the prompt log. So that is how you map it. This is not a demonstration for me to explain how to map prompt log ransomware. It's demonstration of how you can map the next attack for your organization. You need to be able to create a map. It's really simple to create that map. We covered it in this session. So here we're going to go to the next question, but let me check the answers from the first question. We had 11 answers. 100% believe that there is a non-deterministic and emergent behavior. Those are the characteristics that most fundamentally differentiate AI security from traditional IT security. Okay, so that is a correct answer, but it's surprising that 100% knew the answer. So is the level of this course, maybe I need to be more technical. So let me ask you a different question and then we'll see correct answers. So let me go to question. So I'm pushing a third question now. Let me see if it's showing. Don't forget. Okay, so the question is, which one of the following is explicitly covered by MITRE Atlas but not by MITRE attack? Why is this not refreshing? This should refresh. It's possibly that I have to click here.
This is me just being silly with next. Me silly with Slido. Correct. Oh, okay. So now I have to stop the screen share and select the correct answer, and then push the question, and it will tell you. We're gonna do that at the end maybe, because I don't want to start and stop the screen sharing. It's gonna be it's gonna be it's gonna defeat the purpose. So let's move on with the slides, and we'll come back to this question if there is enough time. It's a quiz. And for the quiz to be effective, I need to tell him what's the correct question, what's the correct answer. So once you start typing, it will tell you who won the quiz. Let's go to a second question. From a legal risk perspective, let me push this one. This should work now. Correct. Oh no, this one is not. This is part of the quiz as well. Okay, I'm leaving. I'm not going to do that. No, this is a multiple choice question. It's active. So the question here is, from a legal perspective, rank these attack types from most foreseeable to least foreseeable future today. So I think I'm going to stop using quizzes, because quizzes are not designed for, you have to type the answers beforehand. I have to learn how to use Slido. So I'm going to leave this one open. Please do go and select whichever correct or incorrect answers you might type. And then we'll come back to the Slido questions later. Now, we don't have unlimited time. We only have like 25 minutes left for this session, so I'm gonna have to move a little bit quicker with the slides to make sure that we cover everything before we reach the end of the allocated time. So on this session, I'm just going to mention that AI-enabled malware and autonomous exploitation, like polymorphic malware, metamorphic malware, Black Mamba here, it's a report by Huat researchers that they created a Black Mamba polymorphic malware. They created a polymorphic malware and they called it Black Mamba. What does it mean, polymorphic versus metamorphic? Polymorphic in Greek means many faces, many morphic faces. Metamorphic, it's different. So polymorphic is like chameleon. Chameleon changes its color, but it doesn't change its face. Metamorphic means that the tiger can change into a jaguar. So that, in terms of code development, means that Black Mamba, polymorphic malware, it's not that difficult to detect. Here is the whole diagram that I usually explain how Black Mamba operates, and this is covered in my Pearson classes. But basically, you need to get infected. I'm going to cover it in like 60 seconds. Other sessions, you can watch my Pearson's and O'Reilly courses on how Black Mamba operates, and that's going to give you a much more detailed explanation, including the code. But usually your computer is here, and that device is infected by a specific site. The first security mechanism that you need to put is what kind of sites can infect your computer. That's the first. And if that barrier breaks in and your computer has been infected, Black Mamba is now already on your device. Now, Black Mamba executes Python executive file as a keylogger. Keylogger is when you type something and that's been recorded. The hacker can see everything that you type on your screen. And then that's been sent to attackers via Teams with a webhook. Webhook is a perfectly legitimate tool that every video conferencing software uses. So Zoom uses it, everybody uses it. It's a Python script basically. And that's sent to the hacker's team, to the hacker's team's account. And then in his messages, he can see what you're typing. But your computer will detect this behavior. So what Black Mamba does? It sends out a prompt to generative AI, instructing AI to synthesize new code for keylogging functionality. And then that's generative AI. Doesn't have to be OpenAI, can be DeepSeek, can be Claude, could be, actually Claude has been used for fully orchestrated attacks now. And then the generative AI would send back the new code, and that's how polymorphic, that's what makes the malware polymorphic. It changes the structure slightly every time it attacks, but metamorphic is a lot more dangerous because it's fully changed. Here we have partial changes. Now going to the next slide, here we're going to have a new slide of questions, so let's see how we did with the last one. So from a legal perspective, what ranking this prompt injection as a number one, training data poisoning, model inversion attack, fully autonomous AI exploit. This AI attacks from most foreseeable to least foreseeable today. So this, oh yes, the question was which are the most foreseeable. Yes, the prompt injection is the most foreseeable. Prompt injection is not going to get resolved anytime soon, and it shouldn't. Like it's a form of social engineering, and social engineering is a type of attack that we have hackers that are in prison now in the United Kingdom, and if you give them a phone in 40 minutes they're going to have $1 million in their account just by calling old people and stealing their pensions. So it's very difficult to protect everybody. Sometimes you need to have the rule of law. What is difficult here is that sometimes the hackers are beyond the reach of your rule of law. They could be North Korea, so what are you going to do? Well, you cannot even throw a rock to North Korea. There's nothing you can do, especially if they're AP, advanced persistent threats. So if they're actually state-funded organizations of terror and they steal your data, you're powerless. So moving on to the next question. In your organization or sector, who would currently be accountable if an AI system autonomously causes harm? So I'm pushing that question now, and this is a word cloud. You're gonna get this as a word cloud, and I'm gonna start seeing words here. There's no right or wrong answer. This is a question to you, more feedback to me than in your organization. Who would currently be accountable if an AI system autonomously caused harm? Do you have such person? So who is gonna be there to say, hey, do you have a cybersecurity professional who is paid to monitor this risk? Can you actually blame that person? System admin, can you go to the system admin and say, hey, it's your fault? Because AI has done yada yada yada, it's your fault because you didn't protect this. Can you hold it accountable? Chief of AI in my corporate org. Okay, so please continue typing that and this will come up with something. Let me go back to the slides. We have 20 minutes left for this session. That's why I'm not really spending that much time, although I wish I had more time on the Slido, but then, it needs to be like 4 or 5 hour session. Large language model specific attack vectors in enterprise context. So we have prompt injection, retrieval RAG, APIs, confidential data. In terms of regulatory consequences, breaches may occur without unauthorized access. So, there's no unauthorized access, there's nobody to blame, and they still happen. And compliance must address behavioral misuses. So hopefully this information now it's influencing your decisions. Now I'm going to show you Scheichel-Lund. Scheichel-Lund is an attack. If you don't know what's a Scheichel-Lund, hold on. You see this worm here? That's from Star Wars. It's the worm from June from Star Wars. That is, the worm has name. It's called Scheichel-Lund. So Scheichel-Lund is a worm compromised. That's how the hackers name. Well, that's how we named it. Actually, I don't know how the hackers called it. But it's a supply chain attack, and this is as of the 26th of November. So it's like a couple of months old. And this report here is from Palo Alto Unit 42. So Unit 42 in Palo Alto is one of the top guys in cybersecurity. So they have detected it and they created a report. I'm not gonna read the whole report. I'm just gonna say that this is Scheichel-Lund is a supply chain attack. And we already said supply chain data is very problematic because you don't have control over the organization. The organization might be based in a different country, might be based in the same country, but you don't control what they do. Now we're moving to the NIST. You remember at the very first slide we had MITRE attack, NIST, and I did spend disproportionately more time on MITRE attack because I come from that perspective. MITRE attack is a red team framework, and clearly I believe in that framework more than any other framework because if there is an attack, it tells you how to fix it. The frameworks that I'm going to be discussing now are not really that effective. It doesn't mean that they're bad, but I spent a long time at the beginning explaining that they have different purposes. They're used for different purposes, but MITRE attack is number one if you have a penetration, and it's the easiest to implement because it will give you the solution on the plate. So NIST AI Risk Management Framework is a voluntary but very influential. So everybody in the US uses NIST. NIST, National Institute for Standards and Technology, it's basically all the key cryptographic algorithms are developed over there or approved over there. So most of the security that we have, RSA, ecliptic curve,
That's NIST. Most of the post-quantum cryptography, lattice-based, hash-based, that standard is from NIST. Even in the European Union has adopted it. Regardless of all the internal conflicts, European Union is using NIST-approved algorithms for encryption. So this NIST, what would it help you? To help you with 4 core functions: governing, mapping, measuring, and managing. Because you cannot govern something if you don't understand it. You need to be able to map it. You need to see your attack surface. And the key insights here is that it focuses on the socio-technical risk, not just the technical failure. Quite often, failure is not coming from a technical nature, because systems are designed by default to be secure. So they are designed by default and designed secure by design and secure by default. Actually, I do have a paper on that. Let me show you here. If you go to 2000 digital security by design, that's if you click on that, it will open the PDF and you can read a lot about digital security by design if you wanted to as a further reading. But I think we understand most of the concept now. NIST AI Research Management Framework and Legal Defensibility. So a lawyer should care because it's increasingly cited as a benchmark of reasonable practice. And in law, even that reasonable practice is applicable. So, okay, you're compliant with ISO, but the specific elements are not covered by ISO. What did you do? There's a reasonable practice here. So support for due diligence claims, risk break proportionality arguments, board level oversight evidence. And it contrasts with compliance checklists. So you need to emphasize the process maturity over binary compliance. So that's this. And here we have another question, but before we push that question, let's see how do we have, is your organization sector, who would currently be accountable? And actually my only interest here was to see if there is somebody who is legally, so CEO. Obviously, CEOs will take the blame for everything and they have to resign, but this is the answer I was looking for. None. Quite often, nobody is responsible for AI. And shadow AI is increasingly a problem. And we don't really have approved AI tools to use, and we know how easy and how quickly you can do things with AI tools. So what happened to Deloitte? Just let me close this. I've opened it by accident. Let me type Deloitte AI report. Let's see if it's gonna Deloitte. This is a really large organization, quite profitable, one of the top 4 management consultancy companies. They used generative AI and they got caught. So this is the first time Deloitte cited AI-generated research in a $1 million report. So this was the second time. The first was 400,000, and second time there was $1 million. So if you type Deloitte, so they will pay. This is the first time. So they will pay the money back to Albanese government using AI in 440,000 reports. Why are people doing this? Because they know how much easier it is to build diagrams. Let's say I used some diagrams today. I built those diagrams just before this course. I used AI to build this diagram. But if you show me this diagram, if you build a diagram, I know that this is AI generated. I know the capabilities of AI. I know what kind of diagrams they can create. So it's always the same kind of form. So if you show this to somebody who doesn't, this is designed with napkin.ai. But napkin.ai has like 50 different designs, and it keeps repeating those designs over and over and over, just typing different text that you provide. So it's not really that AI. It's not AI that it generates something new. That's what generative AI means, generating something new. It doesn't have that much power. Quite often it hallucinates using references. Often you cannot rely on generative AI using references. I have a student at this present moment that sends me a draft of the master dissertation, and for the 3rd time I'm telling him I can spot that you're using generative AI to create these references. I'm demonstrating to show you that this reference does not exist. Click the reference 44, 45, 47, 48. They don't exist. I check them, and he doesn't get it. He thinks like, why won't you use Mendeley? So Mendeley is a referencing software. With Mendeley, you can actually create the references in one click of a button here,
and you click that button, it would import the references in your software library. It has a Microsoft Word in-text citation, different button, 2 clicks, imports the reference. But you have to do the work. Generative AI does not have that capability. So why are organizations doing this? Or let's not talk about Deloitte specifically. Most organizations, including Oxford, Cambridge, or every University of Warsaw, how do we budget costing? Full economic costing. That's the term that we use, full economic costing, in Warsaw, in Oxford, everywhere. Full economic costing means that we charge for the cost of this table, of the light bulbs, everything, for the building. And the actual salary of that researcher might be 30,000. My salary is like 30,000, I get paid very little. But actually my fee for Oxford, if you want to hire me via Oxford, could be millions. It will be millions because of the full economic costing. So you see, this person that created that report doesn't mean that he got 440,000. They have budgeted over there all the failed attempts to get work that could be like 50 different bidding things, the expenses for travel, for all that, and they have to recover that cost, and then one guy does that work. I mean, that's how we all do it. Full economic costing, that's how we call it. Now I'm going to push the next question. How credible, hold on, slides. How credible do you believe the NIST AI framework currently is as a benchmark of reasonable practice for courts and regulations? So I'm going to push this as a question. It's ranked from 1 to 5, where 1 is not credible, 5 highly credible. So how credible do you think is NIST? Next, we are moving to AI, to European Union AI Act. We have like 10 minutes left. So my question here is, we covered 2 of the leading frameworks, but specifically 3. Okay, somebody said 3. It's just like, maybe not. Please do use that. I'm not going to be looking at the responses. And by the way, I have no knowledge of who clicks what. It's completely anonymous. I'm going to move on to the next session. So this is ISO. So please click on NIST, and here I'm going to be pointing a few things about ISO, which I wish we had more time, but we don't. So we're going to have to cover this quickly. What is my main criticism of ISO? You see this 225? Let me move my face. This here, report here, 340. So if you want to read this report, this is the ISO report on information technology, artificial intelligence, you need to pay 225 francs. If you want to read this report, which is a combination of 2 reports, you have to pay 340 francs. It's a lot of money. And this is how ISO operates. It's designed for organization, it's not designed for individuals. If you work for an organization, it's asking for ISO compliance, this will have to be paid by the organization. But as an individual researcher, I don't have that budget to pay those fees, and Oxford is not ISO compliant. I repeat, Oxford is not ISO compliant. Many universities in the world, they don't even have the basic ISO compliance, not to mention NIST, MITRE, and all those more advanced frameworks. And I don't think it's ever going to be compliant, at least not in the near future. By Oxford, as a small institution, it has 39 colleges. Each one wants to be independent, and you cannot impose things on them. Actually, you could with ISO. You can say, we all have to be ISO compliant, do it. That's going to create a big backlash. And in organization, everything is about being nice to each other and not upsetting other people. But you see how this could work. NIST is voluntary. And obviously, many security professionals in Oxford, including myself, suggest that we use NIST. So if it's voluntary, who is going to use? Nobody. ISO, if you say you have to be compliant with ISO 42001, there is the report, do it. They will have to do it. So this is where ISO becomes more effective than NIST. So you have different types of ISO then. ISO 42005, another ching, 184 francs. And then you have ISO 42006, ching, 159. It's expensive. It all adds up. If you're an institution, this is nothing. If you're Oxford, if you're University of Warsaw, if you're Google, Cisco, this is nothing. But if you are me, individual, trying to work with ISO, I don't have that kind of resources to pay for these reports. But it provides accountability structures, change management, supply and third-party AI governance, auditability, and documentation. Not really that great. AI bill of material will cover that. Here it will explain that you need to have auditability and documentation, but it's not going to tell you how to do it. it creates evidence trail if you do what they're telling you, but they're not telling you how to do it. So they're working on it. There's many good people trying to fix this. Now, we're going to move to our next question, which is which statement best describes your organization's current AI government maturity? And I hope your answers will change based on this this lecture, because as we're speeding up towards the end now, you have to have a little bit more critical approach towards your organization, not to say, oh yes, we're all fine. But let's see what kind of responses that we get here. Basically, most people say NIST is around 50% good, or 4-star. So some 4-star is kind of winning. Okay, we'll leave it there. We'll move to the next question, which is which statement best describes your organization's current AI government maturity? There's no formal AI governance. Are you aware that there's a government structure? Has anybody been and explained it to you? These are informal policies but no enforceable controls. Which, or do you have are you actively preparing for ISO or AI compliance? A European Union AI Act comes into effect in 2026. Most organizations are sleeping on it. They have no idea that this is coming into force, and they're gonna have a panic attack once it gets into force. But that's what it's designed for, because organizations see security as an expense. They don't see it as an investment. You invest into something that might happen or might not happen. For an organization, this is wow, blows their mind. They're like, how am I going to invest X amount of millions into something that might or might not happen? Why don't I get the insurance policy for that? So I can go back to the slides to see where we are. The European Union AI Act. Actually, from all the regulations that we discussed, this is the last one. Clearly, I can continue and talk all day long, but this is the European Union AI Act is the last regulatory architecture that we need to cover. We covered MITRE, Atlas, MITRE ATT&CK. We covered NIST. We covered ISO. And now we're at the European Union AI Act. We have around 5 minutes, so this will have to be brief. But we have discussed the European Union AI Act on almost every slide so far. So what is the European Union AI Act? Is a regulation on artificial intelligence that is going to come with mandatory penalties if you're non-compliant. So you will need to show where your data is coming from. You need to be transparent. You need to be equitable. How do you do that? AI bill of material is one of those solutions. It's not the silver bullet. It's not going to fix everything. So it's going to be looking at prohibited AI practices and high-risk AI systems and minimal risk systems. So critical shift from voluntary governance to legally enforceable AI control. This is where we're heading. Legally enforceable AI control. There was a question in the chat in the Slido asking, do I think that this is going to slow down AI development? Yes, it will definitely. Is this required? Yes, definitely. So what is the answer? The answer is, what is your risk appetite? In China, for example, they have developed a higher risk appetite for AI, and they said, okay, for this technology to grow, now it's in the infant. Sometimes when we look at infant technology, we are allowed. This is common in business, in economics. Infant industries, for example, are being subsidized to grow and compete with their competitors. AI, if you see it as an infant industry, European Union needs to subsidize it. This needs to be on the list of subsidized. This needs to be replacing the common agricultural common agricultural policy, which is highly ineffective, very controversial policy. Farmers need to be paid fair price, not to be paid subsidies to work. They're not beggars. And that's how the European Union is treating farmers. They're treating them like beggars. So they have to work hard to produce a product, and then the price is being dropped by some external globalization market values, and then you pay subsidies for the farmer to survive, to get like a social benefits. That's not the correct way. Farmers should be paid fair price. But because farming is not an infant industry, farming has been one of the oldest profession. Not to say which one is the oldest profession. Farming is probably the second oldest profession. So it's not new, but artificial intelligence is an infant economy. So this needs to be on the European Union list of subsidized industries. This needs to be subsidized for development in defense, in security, in medical healthcare. Artificial intelligence can cure the cancer. But if you impose these kind of regulations and you're not allowed to share patient data between hospitals in France and hospitals in Germany, that's a problem. Can you share it? You can. You can apply secure multi-party computation and differential privacy. You can. That's what the regulator would say. But you know what? It's going to cost money. And hospitals, they don't have money. So can they apply it? Yeah, give me the money. Give me the money to apply secure multi-party computation. I'm going to do it. The reason why we're not doing it because it's costing you money, and the healthcare services are going bankrupt now with all the different expenses after COVID. So, anyways, so the answer, it's not that clear cut. Is this going to slow down the development of AI in the European Union? Yes. Is this required completely? Yes. You cannot have AI running wild and doing crazy things like, then what if it malfunctions and it's in national critical infrastructure and shuts down all the electricity grid across Europe? These are risks associated with it. High risk AI systems and security obligations. So we have only 2 minutes left on this. So this is the last slide. There is few slides left, but again, I always over prepare. I want to be over prepared than to be under prepared. And I can talk on this for days and days. Actually, some of my courses with Pearsons and Royal are 7 hours long. So I speak for 7 hours without stopping. And people are asking me questions and I respond. But the time is up for this course, and we have covered the regulations that we have, frameworks that we mentioned in the first slide. So this is actually exceeding on that. Security relevant obligations, risk management is going to maintain to be a requirement, and security failures will become regulatory violations. So if you're not complying with those security requirements, it will be a violation. For a security perspective, this is brilliant because it means the accountant can no longer show up and say, hey, you're being paid so much X amount of money and nothing has happened, so why are you being paid? Then you can say, hey, if these security mechanisms are not put into force, you're going to be breaking regulatory violations. You're going to be paying the penalties of 4% of your profit. That's going to be more than the actual yada yada yada. You have counter arguments why this is required. Now, let me just show you. Here we do have more slides, and please do read them in your own free time. Here we have security triad. So this is confidentiality, integrity, and availability. Looking at the AI bill of material. We have some strategic implications for law and business. Maybe we'll cover them when I'm there in person. But this here, it's from Stanford. It's just showing that when the European Union AI Act was developed, Stanford did a study, and none of these models that they're here, none of them was actually compliant with the European Union AI Act. And this includes OpenAI, Anthropic, Google, everybody. None of them was compliant. This is back in the day, so things have changed. Maybe they will have compliance now. And also, questions that you need to ask yourself. Those are questions for the next courses that I'm going to be teaching. Can you identify the main types of machine learning and explain the fundamental differences between them? Because that's going to be something that we're going to teach. And if you don't know that answer, you need to attend my other session. How the gradient descent optimizes machine learning models. In other words, how is machine learning? Do you know that? If not, that's going to be covered in my other sessions. And the most advanced is, can you describe the architecture of, let's say, a convolutional neural network? If you can't, that's going to be part of some of my future courses with you guys. So let's see what kind of questions and answers do we have, and we're going to end it there. So statement both describes informal policies, non-enforceable control. That's the answer that I was expecting. So I'm going to stop this, and we are half past the hour. I'm going to find, where do I stop the sharing? I'm going to stop my screen share.